Welcome to the section 2.2 lecture video. Once again, I am your instructor, Dr. Scott Spaniel, for statistics. Today we're going to talk about section 2.2, which is organizing quantitative data, the popular displays. So similar to what we did in section 2.1 with qualitative data, we can do similar types of things with quantitative data. And so what we're going to do is we're going to look at what those different displays are, what they look like, answer some problems, reading information from those videos, from those popular displays. In this case, we're just going to be talking about histograms in this section. And then once we've done that, we'll go ahead and we'll go into how to make these things using the technology we're using for this class, Google Sheets and ClassCalc. So if you take out your note sheets and turn to section 2.2, once again, those can be found by going to either our Blackboard course in this week, or you can also find these in my math lab, depending on the course structure. So here we go. Categories of data are called classes. A histogram is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency of the class. The width of each rectangle is the same, and the rectangles touch each other. So here are some examples of histograms. So notice we have different groupings. Each rectangle is the same width, and they run into each other. Except when a class does not have any frequency, like down here. In this example, there's no bar there, and that just means that that class has a frequency of 0. So whatever this data is, from 70 to 75, there is no data. Okay. The lower class limit of a class is the smallest value within the class, while the upper class limit of a class is the largest value within the class. The class width is the difference between consecutive lower class limits. All class widths should be the same unless the table is unbounded. So in other words, something like you might do 65 and older for age groups if you were looking at this. A dot plot is the same idea as a histogram, except instead of drawing bars, you just put a dot above the observations each time it's observed. So let's talk about some of these different definitions using the different words using these graphs here. So like if I look at this first graph right here, in this case, the lower class limits would be 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The upper class limits, depending on what type of data we're looking at, would be things like 1 or 1.9 or 1.99 or 1.9999. And then the next one could be 3 or 3.9 or 3.999. It is whatever the largest values that could possibly end up in that group. So in this bar here, the largest values that could show up in there are anything less than 2. Okay. And in the next bar, it would be anything less than 4. So that's why we're saying the upper class limit. And then the class width here would be 2. We subtract consecutive lower class limits. So we just take 2 minus 0, it would be 2. So similarly, if we just look at one more like this one, notice they haven't labeled all the tick marks, so that makes it a little harder. But the lower class limits would be 0, 5, 10, 15, 20, 25, 30, and so on. Okay, so we're going up by 5, so those are the lower class limits. And once again, the upper class limits are just less than that next lower class limit. And in this case, the class width would be 5. So we'll look at that in a little more detail here in a minute when we do some problems, but that's the general idea. Another thing we like to talk about with data like this is the idea of symmetric versus skew. So there are basically two different ways that a graph can be symmetric, and that's to be uniform. In other words, when the graph basically makes a rectangle, all the bars are the same height, or to be bell-shaped, have a hump in the middle, but have it basically make a bell. Those are both symmetric. The other options are to be skewed right or skewed left. So skewed right simply means that there are data values, larger data values, that are pulling out this tail on the right. So the tail on the right is longer. So we would expect this when there's a bunch of data is clumped together, but then there are some data values that are much larger than the rest. But there are not similarly ones that are much smaller than the rest. And then we've got skewed left, which is just the opposite idea of skewed to the right. The tail goes to the left, and so we would expect this when a lot of data is clumped together, and then we have a few data values that are a lot smaller than the majority of the data, but there are not that many values that are larger than the majority of the data. So let's look at some examples that could fall into these different options. So what we want to know here is, are these things going to be bell-shaped, uniform, skewed left, or skewed right? So in this case, number of alcoholic drinks consumed per week. So for me, I would expect this to be skewed right, because I expect that most adults drink somewhere between 0 and 10, drinks a week. But then there's going to be, and so that's where the hump is going to be. It's going to be over near 0, but then there are obviously a few people that are drinking a lot more than that. So that's what would make it skewed right. It would look something similar to this graph right here. Ages of students in public school district. Well, in this case, I would expect this to be uniform, because I would expect there to be roughly the same number of students in each grade. So the ages would be basically the same. Ages of hearing aid patients. I would expect this to be skewed left, because the majority of people that wear hearing aids are going to be over the age of 65, but there are younger people that need hearing aids. And so that's going to draw that tail out all the way back towards 0, right? Because there are even very young children that wear hearing aids. And then the last one is heights of full-grown men. Most likely, this is bell-shaped. Most people are going to fall in the, somewhere between 5'5" and 6'5" probably, but then there's some people that are much shorter than that, and there are some people that are much taller than that. So the tails are fairly even in both directions. Okay, so at this point, pause the video and see what you think about these other 4, and then we'll go through them together. Okay, so now that you've tried these, let's go through them together. So annual household incomes in the United States. So I would expect this to be skewed right, because most people, most households probably make in the $50,000 to $100,000 range. But there are some households that make millions and millions and even billions of dollars a year. So that's going to be a lot of really large data values that are going to skew that to the right. Scores on a standardized exam such as the SAT, I expect that to be bell-shaped. In fact, this is what is called something that's called normal, which we'll look at later on in this course, which makes a bell-shaped graph. Most people fall in the middle of the scores, but then there are scores on either side. Number of people living in a household. I would also expect this to be skewed right, because once again, in most households, there's going to be somewhere between 1 and 5 people. But then there are some people like the 19 and counting people, or whatever their show's called, where they have like 20-some people living in a house, or 19 people living in a house. So that's going to skew that data on the large side, which is to the right. And then ages of patients with Alzheimer's. So I would expect this to be skewed left, because similar to the hearing aids, the majority of people who get Alzheimer's are older, but there are some people that get it at a fairly young age. Okay, so that's the idea. Just thinking about what some of these different data sets would look like. So now let's look at some actual histograms. So if you flip over to the next page, an experiment was conducted in which 2 fair dice were thrown 100 times. The sum of the pips, and those are just the dots, on the dice was then recorded. The following frequency histogram gives the results. So basically what we're looking at here is we've got 2, 3, 4, 5, 6, and so on, and how many times the sum added up to those. And notice that when we only have one data value, when the class has a width of 1, we list the numbers in the middle of the bar. So now we can read this. So what was the most frequent outcome of this experiment? Well, what's the tallest bar? 8. What was the least frequent? So what's the shortest bar? So that would be 2. How many times did we observe a 7? So how tall is this 7 bar? And the answer to that is 15. How many more 5s were observed than 4? So you just need to know how many 5s there were, which looks to be about 11, and how many 4s were there, which appears to be about 7. So that means there were 4 more 5s than 7. Determine the percentage of the time 7 was observed. So how many times was 7 observed? 15. Out of how many? Out of 100. So that would be 15 divided by 100 times 100%, which is 15%. And last but not least, what's the shape of this distribution? Well, this one's close. You might be able to say that this is skewed left, but I'd probably call this bell-shaped. A little bit of a bent bell, but not too badly. Okay, so that's the idea. So let's look at another one. This frequency histogram represents the number of alcohol-related traffic fatalities by state, including Washington, D.C. in 2006, according to the National Highway Traffic Safety Administration. So the first thing they want us to do is determine the class width. So to determine class width, we just pick any two lower class limits, like 800 and 600, and we subtract. So that would be 200. Okay. Identify the classes. So the classes start at the lower class limits. So in this case, I'm going to write them over here. So that would be 0. Right? These are all the lower class limits. Okay. And then the question is, well, what are the upper class limits? So what you want to ask yourself is, what is the largest number that could fall in each one of these groups? So the largest number, since we're talking about traffic fatalities, you can't have a decimal. So the largest number that would fall in this first group would be 199. Okay, so anything between 0 and 199 would fall in that first bar, but then once you hit 200, you move up to this one. And then you can find the rest of these just following the pattern or adding the class width to the upper class limit. So this next one would be 399, and then 599, 799, 999, 1199, 1399, 1599, and 1799. And notice I wrote 1800, but we don't actually use that one because there's no bar for that, so that class doesn't actually exist in this problem. It's just labeling the top of that bar, which is at 1799. So those are the classes in this example. Then it says, which class has the highest frequency? So this is the same idea as what we did on the last one. So which one has the highest frequency? What's the tallest bar? Well, that's the 0 to 199. Describe the shape of this frequency. Well, the majority of the data is over here on the left, but then it's got a long tail out to the right. So this is definitely skewed right. And then the last question here is more a conceptual one about what's reading this data. So it says a reporter writes the following statement. According to the data, Texas had 1,677 alcohol-related deaths, while Vermont had only 29. So the roads in Vermont are much safer. Explain what is wrong with this statement and how a fair comparison can be made between alcohol-related traffic fatalities in Texas versus Vermont. So the problem here is population, right? There are many more people in Texas than there are in Vermont. So what we'd probably want to do a fair comparison is we would want to take the number of traffic fatalities in Texas divided by its population and the number of traffic fatalities in Vermont divided by its population and look at those percentages, those ratios. So whichever one had the higher ratio would say which one was the safer for alcohol-related traffic fatalities. Okay. So what I'd like you guys to do now is pause the video and try these two problems. Okay, so now that you've had a chance to try those, let's go through them together. So what's the most frequent number of cars sold per week? So that's the tallest bar. So that would be 4. How many weeks were 2 cars sold? So this is number of cars sold in a week. So we go to 2. and we count the frequency. So the frequency is how many times 2 cars were sold in a week. So that would be 9. Determine the percentage of time 2 cars were sold in a week. Well, that means we need to take 9 divided by the number of weeks in a year, which is 52, times 100%. So that's about 17.3%. And describe the shape of this distribution. So once again, this one's close. If you're going to call it skewed anything, it'd be skewed right, but I think they're going for more of a bell-shaped here. So I'm going to call this bell-shaped, but it's close to being skewed right. Or actually, no, I bet based on the next problem, either of these I would probably accept. They might be looking for skewed right here. Okay, so it's one of those, but this one's really close. Okay, and then the last question, this question here, same idea. So how many students were sampled? So that just means add up the total, right? So the height of each bar. So we take 2 plus 3 plus 13 plus 42 plus 58 plus 40 plus 31 plus 8 plus 2 plus 1. So 200 total. Determine the class width. We just subtract consecutive lower class limits, so you can pick any ones you want. So 90 minus 80, they just have to be next to each other. So the class width is 10. Identify the classes and their frequencies. So the classes, once again, we can write the lower class limits. And then the upper class limits are the highest thing that fits into each group. So IQs come in whole numbers only. So the biggest whole number that's less than 70 is 69. Then 79, 89, 99, 109, 119, 129, 139, 149, and 159. And once again, nothing fell into 160, so we didn't need that. And then we could label their frequencies. And I'm not going to take the time to write all these out, but it'd be 2, and then 3, 13, and so on. Identify the classes and their frequencies. We just did that. Which class has the highest frequency? Well, that's 100 to 109, right? That's the tallest bar. And which class had the lowest frequency? Well, that's over here. A frequency of 1 is 150 to 159. Okay, so that's how to read one of these histograms. So now what we want to talk about is, well, what if we wanted to make our own? Okay, so choosing the lower class limit of the first class and then determining the class width. So those are the first two things you have to do. If you have data sets with a lot of different values, and so you can't just do like you did in this one where they only had 10 possible answers, so each one of those was a class, you have to figure out what your classes are going to look like. So what you want to do is start out by choosing the lowest observation in the data set or a convenient number slightly lower than the smallest observation in the data set. So you don't have to use the smallest number. You can use a number near it. So let's say your smallest number was 2017. You probably don't want to use 2017. You probably use 2000 or 2010. And then to determine the class width, you decide on the number of classes. Generally, there should be between 5 and 20 classes. The smaller the data set, the fewer classes you should have. So to determine the class width, what you want to do is you want to take the largest data value minus the smallest data value, and then divide by the number of classes. And then you're going to round that up to a convenient number. You're going to round up to a convenient number. So rounding up may result in fewer classes than were originally intended. So you don't necessarily have to use the number you get here. You probably want to round. Okay. So let's look at an example together, and we're going to use technology to do this once we figure out what our classes are going to be. So violent crimes include murder, forcible rape, robbery, and aggravated assault. The following data represents the violent crime rate, crimes per 100,000 population by state plus the District of Columbia in 2005. So if we're going to use 8 classes and we want to choose an appropriate lower class limit for the first class and a class width, you want to start by finding the smallest value, which is 98, and the largest value, which is 1459. Now what you do is the lowest class is 98, so we want to use that or a convenient number less than that. In this case, because our data values end up so big, a convenient number less than that could be 0. So our classes are going to start at 0. Now we take 1459 minus 98 and we divide by 8. When we do that, we get 170.125. And now we want to round that up to a convenient number greater than that. So a convenient number to me that's bigger than that is 200. Okay, so that's what I'm going to use for my class width. These, by convenient, we mean numbers that are easy, but still allow us to separate the data into nice classes. So that means if my first lower class limit is 0, then my next one is 200, and then 400, and then 600, and then 800, and then 1,000, and then 1,200, 1, 2, 3, 4, 5, 6, 7, and then 1,400. And now we can add in the upper class limit. So the upper class limits would be 199, 399, 599, 690, 799, 999, 1199, and 1399, and then 1599. And now if you wanted to by hand, what you could do is you could go through and count up how many things are in each one of these classes to make the frequency histogram. Okay, so we could do that real quick. So anything between 0 and 199. So I like to cross things off as I find them. So anything that starts with is only either 2 digits or starts with a 1 is what we're looking for. So 1, 2, 3, 4, 5. So I think I've got 5 things that fit in this first group. Okay, so now we're doing 200 to 399, so anything that starts with a 2 or a 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I get 22 things in that second class. So now 400 to 599. So anything that starts with a 4 or 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then anything now 670.99. So anything that starts with a 6 or a 7. So 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 there. And then notice, I don't think I have anything else in the next 3 classes. Like I crossed off everything except this last number. So 0, 0, 0, and a 1. And there's my frequency distribution. Now what we're going to talk about is how to deal with this kind of thing using technology. So let's go ahead. Or actually, before, let's go ahead and look at how to do this with technology. So, there's a couple things going on here. First of all, that you should keep in mind. So hopefully you should have all found this spreadsheet in this week's MyMathLab. It's the data set that we're dealing with for this class. And we're in section 2.2, and this is the first problem. So we're looking at the sheet for 2.2, problem 1. So if you want to try these on your own, what you want to do is their directions for this are in MyMathLab, but what you want to do is click File, and then make a copy, and that'll allow you to edit it. You shouldn't be able to edit the original document so that it doesn't change, but you should be able to make your own copy so that you can try these. So what I'm going to do is, first of all, I'm going to show you how to do this in Google Sheets, but there's a problem with how Google Sheets does it that we'll talk about here in a second. which is why we're going to do this also in ClassCalc. So in Google Sheets, highlight the data. You can do that just simply by clicking on the A column here at the top, and then click on this thing that looks like a little bar graph, and that will insert a chart, hopefully. Yep, there it is. Now, here's the thing about Google Sheets. This works fine. You can use this graph, but there's a couple of interesting things here. There are only a few options to edit this to fit the widths and things we're looking for here. So you can change what type of graph you're looking at up here. And then we can go to customize. Okay, you've got chart style, which just changes colors and things like that. Then you've got the histogram. Now, the histogram is one of the things we want to talk about. Right now, this is set up to do our bucket size. Now, the bucket size is the same thing as class width. Now, this is the problem with Google Sheets, is I can't make these class widths big enough for what I wanted to do, right? 50 is the biggest they get, and that got me a lot of classes. So that's really the biggest problem with Google Sheets. And then there are some other options for how to change this. So what we're going to do instead is, instead of using Google Sheets, what I want to do is I want to use ClassCalc. So what we want to do is we want to copy this, which you can either go to Edit, Copy, or you can use Control-C if you're on a PC, or Command-C if you're on a Mac. We're going to copy that, and then we're going to go over here and we're going to paste it. And to paste it, you have to use the shortcut. So the shortcut keys are Command-V or Control-V. And it should paste your data in. Now, what I like to do, the first thing I like to do is I like to change this header on my table. Instead of having it be X1 with a subscript, I like to put in another letter. So I'm just going to use A. Okay? Because that makes it easier to deal with. So now what we're going to do is we're going to go to if you ever don't have your keyboard down here at the bottom, just click these up arrows, and here's my calculator keypad. I'm going to go to Stat. I'm going to go to Distribution or Plot, because I'm doing a plot. I'm doing a histogram, and then I'm going to choose histogram. And before I do that, I want to make sure that I'm in number 2, so that I'm not in this one where my table is. So I'm in number 2, and I'm just going to choose histogram, and then I'm just going to type in an A. And then it's got the word bin width down here. Bin width is where you can add your class width. So our class width, we said, was going to be 200. So I can put in 200. And then if I zoom out, I can zoom to my data by using this little magnifying glass over here. So click on that. Now notice this made a really weird looking graph. So we're going to want to change that. So you can change that by going and clicking this thing up here that says rad on it right now, and it's got some sliders. It's the settings for the graph. And what I want to change is I want to change my x-axis and my y-axis, but specifically the y-axis. So for y, I just want this to start at like -5, so I'm just below the x. And then this y, I'm going to make into 30. And if I do that, it didn't work. Why didn't it work? Let's try this again. It's being stupid right now for some reason that I don't understand. So let's try this one more time. Okay, so let's just try changing both. So let's make this -5. Yeah, okay, now it's working. I'll make this, our largest class number was 1500, so let's make this 1600. I'll go for my y-axis. We could actually just make these 0. For my y-axis, start at 0, and then I'm going to go, I don't want to make it too tall, so let's go to 25. Okay, and there's my histogram. Okay, and if you wanted to zoom out a little bit, ooh, it zoomed out a lot. So that didn't work really well. Let's try this one more time. So I'm going to put -5. And then I want to go over to be bigger than my largest class. So let's call it 1700. Because my largest class is about 1600. And then for y, we're going to go from -5 to 25. Okay. So notice there's a couple things I did here on purpose. to make things a little easier to read, let's make this negative 100. So I can see my axes on the side. I made my x's bigger and smaller than my lowest class and my largest class. And I made my y-axis lower and larger than my data value so that I can see the whole graph. So that's why I did these -5s and -100. And now notice if you click on these dots or you hover over these dots, it'll tell you the bin and the count. So, and that's exactly what we got in ours, right? We saw that the first bin was 0 to 200 and we got 5. The second bin was 0 to 200 to 399 and we got 22. Now, the thing you have to be careful about here is, remember, this upper number is not actually in. This 400 is actually in this bin. Okay? And so there's our histogram. Okay, so at this point, if you wanted to pause the video and try the last problem in our note sheets on page 15, you could do that. And then here in a minute, we can try doing this graph together. Okay, so for this problem, we're going to do the exact same thing we did with the last one, which is we need to start by figuring out what our smallest class limit is, and then we want to figure out how wide we want to make our classes here. So in this case, I want to do the same thing I did previously. I want to find the largest data value and the smallest data value. So let's give that a try. So for largest, I think the largest is 2359. And for smallest, I see some 6s. Yeah, it looks like the smallest one is 637, 6.37. So in this case, I probably want to start with my lower class limits. Instead of at like 0, because these are so close together, I probably want to start at 5 or 6. So I'm going to choose 6. For what I'm going to do by hand. And then we need to pick a class width. In most cases on the homework, they're going to tell you where to start, and maybe even the class width so that you get a fairly good even distribution for these, and so you get the same answer. So then I take 23.59 minus 6.37, and I divide it by the 6 classes they told us to use. Okay, get our class width. So when I get that, I get 2.87, and so I'm going to round up to 3. So my classes are going to be 6, 9, 12, 15, 18, and 21. So that's 6. Now we go to 2 decimal points, so it's 6 to 8.99, 9 to 11.99, 12 to 14.99, 15 to 17.99, 18 to 20.99, and 21 to 23.99. Okay, and now I just need to count up how many are in each class. So let's see what we get here. So so anything that starts with a 6, 7, or 8 goes in the first class. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 go in the first class. Now we want anything that starts with a 9, 10, or 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I've got 9 in my second class. Now we want anything that starts with a 12, 13, or 14. So 1, 2, 3, 4. Now 15, 16, or 17. 1, 2, 3, 4. And now anything that starts with an 18, 19, or 20. So 1, 2. And then anything that starts with a 21, 22, or 23. So 1. And so there's our frequency distribution. And so now we can use our calculator to do the exact, make a histogram again. So I'm going to copy this, so Command C, then I'm going to paste it into number 1, so Command V. Then I'm going to change the name at the top to A. You can use any letter, but I just like A because it's quick and easy. It's the first letter of the alphabet. And then to make a histogram, I go to Stat. I'm going to go to Distribution or Plot. I'm going to go to Histogram, and then I'm going to type in my letter A, and then I'm going to type in my bin widths, which is 3, and then I'm going to hit this Zoom button to zoom in on my data. And there it is. And because this data set was smaller, it zoomed in nicer. And then if I highlight the tops, I get this. One of the nice things about ClassCalc versus Google Sheets as well is that it tends to be a little smarter. So notice that when we put in a bin width of 3, it picked exactly the same lower class limit and made it look exactly like our graph. Okay, so that is the end of section 2.2. So this is the end of this lecture video. If you have any questions, as always, feel free to contact me through email or Remind, and we can set up a time to talk. And if you have, don't forget to do the homework and quizzes.